Unreal Engine feels overwhelming? Well, this video is for you. You'll go from zero experience to building a playable game step by step using only the most important Unreal Engine features. If you are curious to learn more, or if you just have any questions about this video, I created a brand new Discord server where you can talk with me one-on-one or just ask a question to the community. The link is down in the description. So before we build anything in Unreal Engine, we first need to understand how to work with it. So let's quickly take a look at Unreal Engine's layout. Unreal Engine is made out of 4 main panels. Number 1 is the viewport. Here you can place assets to build your level. When I select an asset, you see the gizmo popping up. And with this, I can move the asset however I want. Pressing W will put the gizmo into move mode. Pressing E will put it into rotation mode. And pressing R will put it into scale mode. Or you can just use any of these buttons at the top. The outliner shows you all the assets that currently live in your level. So let's make this a little bit bigger. Right now I have this asset selected, but I can also just select any other asset and it will just select that one in the viewport as well. When clicking on anything in the outliner or the viewport, a new panel pops up, the details panel. Here you can change a lot of the setting per asset, like location, rotation and scale. Scrolling down, I can also change the mesh. Let's say we're gonna make this a cylinder instead, and right now it's a cylinder. I can enable or disable physics. So for this asset, physics has been turned on already. What that means is if I just put this up in the air, it will fall down automatically with gravity. And so there's a lot of different kind of settings that you can tweak on any of these assets. But you might be wondering, where are these assets created? Well, when you press Ctrl and space, you will open the content drawer. And this is where all your assets in your project are stored. From blueprints to levels to custom meshes to animations, everything is in this one place. To create an asset, you can right click anywhere in the content drawer and then you can just select anything you want. We're going to create assets later on in this tutorial, but for now I'll just drag a mesh into the level, like this. Unreal Engine can do a lot of things, but we're here to make games. So let's define what kind of game we're actually building. I want to build a Fall Guys style physics-based parkour game with different kind of obstacles. For the sake of this tutorial, I leave out multiplayer and make this single player instead with a timer on top of the screen. In Unreal, everything that does something is an actor. We're going to cover actors a little later in this tutorial, but an important type of actor is the character. This actor already has movement, collision, and a lot more functionality built in. If you've selected the third-person template when making your project, you will probably have these folders. And in this folder, you have the third-person, blueprint, and then the BP_third-person character. If you don't have this template enabled, you can easily create a character yourself by right-clicking the content drawer, blueprint class, and here you have character, and you can just call it anything like my character. So when opening the Unreal Engine character, it will open the third person character blueprint actor, aka our character that we're going to work with. This will also have a viewport, so we can visually see what our blueprint looks like. In this case, it's the Unreal character. And we also have an event graph, and as you can see, there's quite a lot of nodes that are made by Unreal Engine when they made this character. And if you've never seen nodes before, this might overwhelm you, but don't worry. All this really does is it makes sure that a character can move around, it can jump, and you can look around with your mouse. So that's really nice. We don't really have to worry about figuring out how to make the character walk. It can already do that. Let's say you do not have this template and you do have this my character. This, of course, does not have a mesh. It also does not have any nodes, so you will have to make this yourself. But for now, I'm just going to use this third-person character created by Unreal Engine. So if I now go back to my level, you don't really see the character being anywhere. And this is, well, we have this player start here. And how it works is it will just automatically spawn in my character at this location. So if I now press play, you will see my character spawned in the level. We can move around, we can jump, and we can also look around. So that's basically all those nodes are doing that are right now in the player character. Now, movement alone isn't enough. We want the player to feel good to control. So we're gonna spend some time on the character feel. Back in the third-person character, you will see you have a character movement component. In this character movement component, we can adjust the movement metrics of the character to your liking. You see you have some general settings. You also see you have custom movement modes like walking, jumping. This is for multiplayer networking. You have swimming, flying. So a lot of these settings we don't really need. But some settings to be aware of are, for example, the acceleration, the max walk speed is quite important. And if your game has crouching, the max walk speed crouched is also important. The jump Z velocity decides how high your character can jump. And the air control, how well you can control your character while it's in the air. So for example, the default jump Z velocity is 420. Let's put this up to like, let's say a very high number, like 10,000. Compile and save. We play the game. You see we jump really high right now. So in Fall Guys, the jump height isn't that high, but the character does stay in the air for quite some time. So what I'm gonna do, I'm just gonna decrease the jump velocity and also decrease the gravity a little bit so it stays afloat a little longer. I think something like this is quite nice. The jump is a little bit lower. I'm staying in the air for a little longer, just like Fall Guys. Now, I also feel like the character in Fall Guys is quite slow. So I'm just gonna decrease the max walk speed a little. Maybe like 400 is nice. And this really is just about what feels nice, what you want to create, what kind of game you want to make, stuff like that. Like, for example, in a horror game, you probably don't want the character to walk too fast. Whereas in a platformer, if the player is really slow, that's also kind of annoying. But I feel like this is pretty good in terms of player metrics. And usually when making games, this is one of the first things you'll be doing. Cameras can make or break a game, especially in platformers. The good news is, tweaking a camera is a lot easier in Unreal Engine than it sounds. So let's take a look at it. So in Fall Guys, the camera is quite high up, like a lot higher than my camera right now. And I can easily change this camera by going back to my third-person character. And in the viewport, you'll see this camera. And you can literally just move it up. And as you can see, if I just move it up a lot, you're not going to see my character now on the camera probably. You'll see like the camera is now very high up. So I feel like the camera is a little bit down like this. And then a little bit rotated like this. You notice the camera is a child of this, of the camera boom. And this is like a spring arm component. So what it does is you can enable like camera lag or adjust like how far the camera is from the player. It just makes like working with cameras a little bit nicer. So I would always just recommend having a spring arm component in there and then your camera being a child of the spring arm. So right now I made the camera a little bit higher and I tilted it a little bit down. So I'm curious how it looks. Yeah, it's getting there. So here I feel like the camera should be a bit more further away. So that's where I would use a spring arm component for. So the camera boom, the target arm length is now 420. I'm going to increase that a little. Compile, save, play it. Yeah, I feel like this is quite nice. Additionally, you can also add some camera lag here in the camera boom. I'm just going to play around with it, see if I like it or not. So I enabled the camera lag and you'll see it's a little bit slower when I move the mouse. I don't think it's nice for a platformer game, so I'll just disable it. And now I disabled it, you'll see the camera turning is just instant. At this point, we know what game we're going to make, we have a player, and we can move around. So let's start with gray boxing our level. And this is the process of placing rough shapes to make our level. And it's going to look rough, but that's exactly the point. What we do need to understand before building the level is what our gameplay ingredients are. What ingredients make our game fun? So in our case, the gameplay ingredients for a platforming game are the obstacles. So let's take a look at a reference game, Fall Guys. To make the level interesting, I've chosen 7 obstacles to remake. So first I'm going to make a simple block out of the gameplay ingredients so we can easily copy and paste them over our level. And then we lay these obstacles out in the level. And then once the layout feels right, we'll start giving these obstacles functionality. But before anything moves or interacts, I want to understand how the level reads and flows. I'm going to use the modeling mode in Unreal Engine, which you can find in the top left, and then just select modeling, or just press Shift and 5. It will open up this menu and you can easily create a static mesh using this menu. There's also another way of making meshes. You just have to open up Window, Place Actors, and then you will see this geometry button right here, and you can just drag and drop your assets here. I like using the modeling mode a little bit more because it gives me more flexibility on how I shape my assets. So for now, I'm just gonna delete this box brush that I placed from the Place Actors panel. I'm also gonna close this Place Actors panel because I'm not gonna use it. So my approach will be I'm just gonna place a bunch of simple meshes into the world, like boxes, spheres, and cylinders, and I'm making my gameplay ingredient out of it. And when I'm done with making this obstacle, I will group these assets in the outliner so I can easily just copy and paste them around. When you are going to use this approach, I would first look at your new asset location, which by default is set to auto-gen folder. What this means is it's going to create a new folder. I don't really want that. I want to create a folder myself. I'm just going to create a folder here called just meshes is fine. Open this folder, and then you have the option of just saying current folder. There we go. And now when I'm going to create, for example, a box, just a simple box, it's a cube. I press accept. Now there's going to be this cube, which I can freely use anywhere I want. For now, I'm just going to delete these cubes. And if you guys want, I can make a separate tutorial about the modeling tool in Unreal Engine. Just let me know in the comments if that's something you would like. So what I'm going to do actually is I'm going to make a new level. Just leave this level as is and just have a clean level without this in place. So the best way to make a new level is by going to File, New Level, and then you have a bunch of options. I don't really have an open world level. It has level streaming and all that kind of stuff. I just want a basic level with some lighting. So if you would choose for empty level, you would not have like lighting. You would not have this kind of grid to work with. So it just places it for you. As you see in the outliner, there are some things that are already placed in the level, which is really nice. So this gives us something to work with. So on this plane right here, I'm going to create all these different kind of gameplay ingredients. I want to start with the slow down ledge with the rotating hammers. I think this is going to be really easy. Open the modeling tool again. Oh yeah, make sure to save your level because we just created the new level. I'm just going to start with just adding a box here. And then with the depth and the width, you can create quite a big shape out of it. So I would like to stick with like numbers in 50. So 450 or 400 or 500. As you see on this grid, these are like 100 units. The small squares are 10 units. So these are Unreal units, which are kind of like centimeters. You can see it. So for now, just gonna start with width 200 and depth 500. And a good way to test is always just playing through it. So I'm going to click on this button and I say spawn player at. Otherwise, it will spawn me at the player location, which is over there where the players start, I should say. And now when you press play, you can play through it. You see this is already like very small. The one issue with this tool is you cannot just select it and edit the model. Well, you can, but you cannot change like the parameters like the width and the depth anymore. You can scale it here, the details menu. So since we only really care about placing shapes quickly, we can quickly just edit these numbers right here to get a shape we kind of want. You'll see we stretched the mesh quite a lot, but that doesn't really matter. We're going to replace these anyway with an actual asset. If you would be really making this game, you would replace this asset anyway. So for now, we're just testing out if this scale feels good. So I'm just gonna drag this out a lot more. Something like this. Play again. Yeah, it's getting close, I feel like. If you've created your project with starter content, you should have this prototype grid material. If you click on box and you give the material prototype and then grid, it will now just place a prototype grid for all of these assets. And you'll see like the grid will always stay the same no matter where I place my box. Now when I open box again, you'll see it's automatically assigned. So I don't have to change the material every time I want to place an asset. So we now have kind of like our plane for the very first obstacle. So for the hammer, I'll just create a cylinder. The radius can be a lot smaller. I feel like this is all right. Maybe scale this up a little bit more. Maybe what I want to do is make the obstacles quite big. Like in Fall Guys, the obstacles are quite small because, well, the characters are quite small as well. But let's just try to make this hammer quite big. I think that would work a little bit better. So we can just easily scale this up like this. Play it. Yeah. And now we're just going to give it a huge hammer. And as you can see, if you just place another cylinder, it will just snap to the cylinder that we already placed, which is quite nice. So I just want to do this. And then finally, we're going to give it a huge cylinder at the end. Something like this, maybe. And of course, this like hammer, it will spin around to create a bit of a challenge. Yeah, I think that's quite nice, actually. It's quite nice. Maybe what I want to do is scale this up a little bit more so this kind of structure is the same height as my character. So what you can actually do is you can just drag your skeleton into the level to check for scaling. So I don't have to like play the game and quit out every time I want to check scaling. You can see it's the exact same character. So by just dragging this around, I can just check, hey, how big should this obstacle be, for example. So we want this to be the same height as my character. So just gonna select all of these, press R for scaling mode, and just scale it up a little bit more, drag it up. I feel like it's pretty much there, a little bit more. There we go. Yeah, I feel like it's quite nice. Also with the camera, it's quite high up, so you can kind of peek over the obstacle like this, while the obstacle still looks quite terrifying with how big it is. Okay, cool. We have a first obstacle created. Now what we're going to do is quite important. We're just going to select all of these, and then you can either press Ctrl and G or just group them like this. And this will create this grouped actor. Now every time we select one of these assets, all the other assets will also move. And if you want to ungroup them, you can just simply press Shift and G, and that will ungroup these assets again. Cool. Now the last part of this obstacle, we're just placing them around like this. And in Fall Guys, they're kind of just everywhere really. Also like here in the middle, there's not really any like symmetry or anything about that. Just make it a bit challenging like this. Don't make it too difficult though. Still want the player to be able to complete this level. Alright, cool. So this is our very first obstacle course. Of course, it does look very rough, but we're gonna add some colors to it later. And then when we're done with the colors, we're also, of course, gonna make this all work. So this will be a slow platform, so the movement speed will be pretty low, and these things, they will just be rotating, and when it hits the player, it will be launched backwards. Now, one thing that I like to do is select all of these. So this is the full obstacle course, and just move this to a new folder called Slow Down Ledge with Hammer. There we go. The only thing that remains is the character that we're gonna just move to another place where we're gonna make our second obstacle. Now the next obstacle is also just super simple. It's gonna be a circular platform with just one rotating stick. So again, we're gonna go to the modeling mode. I'm gonna start with a cylinder this time. Just click in the level and give it quite a big radius like this. It doesn't need to be as big as the other one because we're gonna place a couple of these into the level, and you would kind of have to jump from one platform to the other. Well, there's a stick just rotating here, so you need to time your jumps. So if you just want to scale the X and the Y axes, like right now I don't want to scale it up or down, I just want to scale it on the X and Y. You can kind of hover over that, it just selects the X and Y axes, and then just drag it out like this. You'll see it doesn't impact the Z axis at all. I feel like this is a nice scale for it. So now we're gonna create a stick. So just place another cylinder kind of in the middle, scale it down, make it a little bit higher. We're gonna place it exactly in the middle. Now we're just gonna add a massive stick, which is just gonna be a box. Just scale it down a lot, and then just make it really wide. Gonna place it like inside of the cylinder, like this. Make sure it's in the middle. Gonna make it a bit wider. There we go. Now it covers the entire cylinder. And you can already kind of see if it works by just rotating the stick like this. And well, looks pretty nice. And that's our second obstacle done. Don't forget to put this in a folder again. And we're going to call this a circular platform with stick. Now, if you want to just select the entire obstacle, we can just right click and then select. And then we'll just do all descendants. So I spent some time and made some more blockouts. So now we have all the 7 obstacles. And now the final thing I'm going to do before building the level is I'm going to add some more colors. Right now everything is very gray, and I want, for example, obstacles to have the color red. So that's actually very easy to do. We just click on one of the meshes, we scroll down till we see the material that we used. So that's just this square grid. Then we look for it in the content browser using this button. And that will bring us to where this asset is saved in the content browser. Now we're going to make a material instance. So that's basically just a child of this material. And what we can do with it is very easy and pretty cool actually. We're going to call this m_prototype_red. Now if we open that, you see we have a lot of properties we can edit. So I want to change the surface color. Right now it's gray by default. And I want to change this to red. And instead of this gray ball, we now have this red ball. The ball is just an example of how the material will look. Just gonna save this, close out. And if we now give this, for example, the stick, the red color, you'll see it now has this red color. Very nice. And now imagine we would change this master material as well, then this child material would change with it. But we're not going to cover materials in this tutorial. It's a little too advanced. If you do want a tutorial about materials, just let me know down in the comments. So yeah, I'm just going to give every obstacle the color red. I like to do this personally, but you don't have to do this. I just like doing it. Now I'm doing this before I'm building the level. Because if I would have built the level already, I have a lot of duplicates of these obstacles. And I would have to go past each duplicate and also just give these the color. So yeah, that's why I'm doing it now. If I duplicate, for example, this one, all the duplicates will also have the red obstacles. And I'm going to do the same, but for the color of orange. And the orange ones, I'm going to use for all the moving platforms. If you want, you can also just shift and right click on the materials. This will copy, and then shift and left click to paste it. It's a little bit easier. Then I'm going to give these rotating pillars a blue color. So we open it, click on surface color, just give it the color of blue. Now this is a bit dark, so we want to make it a bit lighter like this. I think this is a nice color. Make sure to save it. And then we're gonna give all these obstacles, these rotating pillars, a blue color. And again, if you click it, it will now say there's multiple values. So what we can do is just Ctrl-Shift-G to ungroup them. We click it, we scroll down, and then we copy it. And we're just gonna give all of these the color of blue. And it's very easy to just select one of them, shift right click, select another one, shift left click. Good for all of these. There we go. I feel like this looks a lot nicer and just more appetizing to play, honestly. And besides it looking nice, it also has a function because, of course, like all of these colors, they indicate they do something different. So, for example, the blue ones, they rotate. The red ones, they're kind of like obstacles. They should like push you away. The orange ones are moving platforms from left to right. And these red balls, well, of course, they will just swing around. Same with these ones. So they all have kind of this function where the red ones, they push you away. The orange ones just move from left to right. The blue ones, they will just rotate in place. So I like making these slow platforms purple. Why? It's just because Fall Guys also has them in purple. So we go to the content drawer, right click on our master material, create material instance, m_prototype and purple. Open it, surface color, you know the deal, make it purple, thing like this, a little bit brighter, like this is nice. Save it in the top left and give the floor the color of purple. There we go. And this floor is also a slow platform. So where you fall off, you just land on this, you have to walk back and walk up again. I should probably make like a ledge here so you can walk on it. All right, I've expanded this obstacle a little bit. It now has this kind of like ledge and this platform you start on. And I made this section a little lower so it doesn't take too long to fall down. And I've given colors to a lot of things. So all these colors, they mean something different. We've done all this preparation now for the fun part, building our level. So as you can see, I've grouped all the obstacles. And this way I can easily just alt and drag to create a duplicate. This makes building a level really easy. If you want to delete it, just press delete, apply to all, and it will just delete everything that was in the grouped actor. All right, let's start building our level. So I'm gonna start with placing down some of these like propeller obstacles. It's not too difficult of a challenge. I'm also placing some of these obstacles in the way. I know Fall Guys did it. I'm gonna make it a little bit smaller. Something like this might be nice. Then we're gonna place one of these over here, a bit smaller like this. Make sure the player can't jump over this. Right now it looks like it can, but in reality they can't. So let's make this a little higher. So it's clear to the player that they cannot jump over this. This is pretty clear. Do this for the other side as well. But I kind of go from the middle to the left to the right. I feel like that's a nice start to our parkour level. So remember, we're not making any functionality yet. I'm just laying out the level itself. Next, I'm just going to drag this into here. We also want the level to go up a little bit. So we can easily do that by selecting this, group all of these, Ctrl G, and then rotate it a little bit. Something like this might be nice. Yeah. Then you have this section with the obstacles moving left to right. We're also going to implement checkpoints in a bit so that when you fall down, you don't have to start all the way over again. Also gonna make this a little bit smaller, this section. Also give the player a little bit of a start. Oh yeah, quick tip, if you want to change the layout of these obstacles, you can just press Ctrl Shift and G to exit the group mode. Then you can adjust, for example, this. Then press Ctrl-Shift-G again, and it will be the same group, but the location of this obstacle has changed. It's a pretty nice way to adjust assets in a group that you've already made, and you don't have to ungroup and group them back again. You can just do Ctrl-Shift-G, Ctrl-Shift-G again to toggle group mode. So I now made a little player start. It's very small. Then I'm gonna add some of the swinging balls. All right, so now we have 3 of our obstacles. Next, I'm gonna add some of these circular platforms. Make sure to test your level to see if the jumps are feasible. In my case, they're not. I need to adjust the location a little bit. I also think I want to make some elevation in platforms. So up a little bit higher, like this, like this. I think I'm also gonna make these platforms a little bit smaller. And I can easily do that by pressing Ctrl-Shift-G and then just Control and selecting all of these. All right, I've placed some circular platforms. It also has a little bit of elevation, but since the character can't jump too high, I couldn't give it too much elevation. Now I'm gonna place this obstacle. All right, then the timed platforms. And then lastly, we're gonna finish with a bit of a climb past these rotating hammers. We're gonna angle it 10 degrees, or minus 10 degrees rather, for a final climb towards the finish line. Like we did with the starting section, also create a bit of space for the finish line. Cool. So that's our parkour. And I mean, we can easily expand this, of course, and reproduce some of these challenges by just selecting one, holding Alt and dragging it. For now, I want to just make the functionality for these obstacles, then test it, see how long it takes, and if needed, make some adjustments to the level. So the next part will be making these obstacles actually work. So now we have a player and a level to move in, but nothing really happens yet. And that's where gameplay logic comes in. Remember earlier in the video I mentioned actors? We're gonna put them to use to make our game work. All right, so we know what our obstacles are. We have our block out of the level. And now the most important part is making these obstacles work. So for this, we're going to use blueprints. And if you've never used blueprints before, I'll just guide you through it. So even if you're a beginner and you've never used blueprints before, you'll still be able to follow along, hopefully. So all of my previous videos have been tutorials on blueprints. So if I talk about something that I've covered in one of my previous videos, I'll quickly highlight that video on the screen like this. All right, let's get started. So to give you an idea of what blueprints are, I'm quickly going to make a blueprint. So just right click anywhere in your content browser. Click on blueprint class, click on actor. You're gonna choose actor 90% of the time. And for now, we just give it a BP underscore test. With blueprints, always just have this naming convention of BP underscore and then the name of your actor. So in BP test, I'm gonna open it. It will show this. I've covered this earlier in the video, the viewport where you can see the visual of your blueprint. But the most important part of your blueprint is here in the event graph. And one of the most used nodes is the print string node. If I can type it, there we go. And what this does, it will simply just put a message on the screen. So this is like the hello world that you might know from other coding languages. We compile and save in the top left. Make sure you don't forget to drag it into the level, otherwise it won't work. Here we see our blueprint. Well, we don't really see anything. We just see the gizmo and this little like circle icon. But when we press play, you'll see in the top left, it will say hello. So that's kind of the whole idea of blueprints. These single nodes, they will do something for you. And with that logic, we're gonna make all these obstacles work. And if you're a beginner and you've never seen blueprints before, this might overwhelm you a little, but I'll guide you through the process so you are able to use blueprints after this video. Each of these obstacles will get their own blueprint because, well, they have their own kind of functionality, right? So I'm gonna start with these rotating hammers. So what I'm simply gonna do is to keep things clean, I'm gonna make a new folder called obstacles, I guess. Then just like I did last time, right click, blueprint class, we create an actor and we call this BP underscore rotating hammer. There we go. So what I'm gonna do is I'm basically gonna remake these meshes, but then in the viewport of the blueprint. So how do I do that? It's really simple. Just click add here on the components tab. We'll start with a cylinder. Again, these are very like basic shapes, but that's fine. We're just making a prototype now. If you do want to extend this further, you can make models in Blender to make it look pretty, but that's out of the scope of this tutorial. So we're gonna make this a bit smaller, like this. Then we're gonna make another cylinder. So just search for cylinder. There we go. I'm gonna scale this and we're gonna rotate this. Scale this like this. put it here, then like this, it's fine. Shove it in a little bit more into the original cylinder. And then finally, we're gonna make this red part. So again, we're gonna add a cylinder. Then we're gonna scale it down a little bit. This, scale it down on all axes maybe. Gonna recreate what we had, maybe make it a bit longer. It doesn't have to be perfect, right? It's just to give you an idea, just to make a little prototype. Can be a bit longer like this. And I think this is fine. Yeah, it's in the middle. So because this is the parent of these two children, you can see it here. This is the parent and these two other children. When I rotate this parent, the other cylinders will move with it, which is exactly what we want. So we can just make this cylinder rotate and not have to do anything with these two. All right, so let's actually do that. Let's go to our event graph. Opening the event graph, you'll see these 3 red nodes. These are events. You can basically see them as firing of a gun. They basically start a sequence of functionality. For example, this will start on begin play. This will start when something overlaps, like a player overlaps with my meshes. An event tick runs every frame. Let's say I'm gonna do this, print string. Now this will activate every frame. If I compile and then drag my hammer into the level, don't forget. And now I press play, you'll see it prints hello every single frame, 60 frames per second, maybe even more. So you do want to watch out with event tick because as you might tell, it can also bloat your performance, especially your CPU, your processor on your computer. So use this event with caution. Sometimes you just have to use it. I'm not saying you should never use event tick, but be careful with using it. But for rotating the hammer, I am going to use event tick. So what we can do is we drag out of event tick and say add actor local rotation. So this will just make the actor rotate. Then we can say on what axis we want the actor to rotate. So let's say we give it 10. Now every tick, it will give 10 rotation. So what does that mean? If you look here, you'll see this is like 10-degree rotation, right? So what does this do? It will give a 10-degree rotation on every frame. So every frame, it's going 10, 10, 10, 10, 10 like this, right? So if we test it, click on play, you'll see it starts spinning. But it is going quite fast and we cannot control it. So what we can do is right click and split struct spin. And this will, instead of a rotator, so the 3 values combined, X, Y, Z, it will split these rotators into 3 floats. And floats is a variable type that we use a lot. They are numbers, but not just numbers, they can have decimals. Integers, on the other hand, are full numbers without decimals, and these green pins are floats, and they can have a decimal. So now we can, for example, say 1, because we thought it's spinning way too fast. And right now you can see it's spinning very slow. Awesome. But of course, different computers have different frame rates. So right now, with this logic, it would spin at a different speed based on your frame rate. And we don't want that. And that's why you have this green float called the delta seconds. With this, you can make sure it is not frame dependent. So what we're going to do is we're going to make a variable here on the left. We're going to call this spinning speed. And we're going to make this a float. Then we drag it in. We say get. And then we're going to multiply. So just press a star. So just drag out and press a star. And we're going to multiply it with delta seconds, right? To keep things clean, I'm going to switch these around. So just Alt and click on a line. It will remove that line. And we're going to use this as the delta rotation. So now this value will multiply with my spinning speed, which is a variable I can control. If I compile, I can give it any value I want. I can give it like 20, for example. It's probably going to be way too fast. Or way too slow, actually. And we can bump this up to like, what, maybe 200 in that case. There you go. That's quite nice. Maybe it can be a little bit faster. And instead going back to our blueprint every time to change the value, we can also click this instance editable checkbox, compile save. And now if we go back into the level, you'll see if I select the rotating hammer in the level, on the right side, in the details panel, you see spinning speed. And we can drag it out, we can play around with it, and it's a lot more convenient than having to go into the blueprint every time I want to change this value. So I thought it can be maybe a bit quicker, so let's give it like 250, and I think this is perfect. Okay, so we have the rotating part done, but now I want the player to be launched whenever it hits the hammer Also, quickly, I'm just gonna give it some color as well, just like these ones. I can do that in the viewport. If I just select this was blue. I think it should be in there still. There we go. This red. There we go. So this rotates this way, right? Clockwise. So I want, if this round part at the front hits the player, it rotates like this, right? Then I want the player to be launched away. So I'm gonna make a collision here. A collision that would detect the player, because I don't want this part to detect the player or the cylinder itself. I only want this part to detect the player. So what I'm gonna do, I'm gonna parent it to this red mesh again. So when this mesh moves, the collision will move with it. I'm gonna make a sphere collision. You have multiple collision. I will quickly show you. You have the box collision, capsule collision, and sphere collision. So a box will look like this. It's literally just a box. A capsule collision looks like this. You usually use this for like a player character. It's by default also on the Unreal character that we're using. It has this like capsule collision. And lastly, what we're gonna use is the sphere collision, which looks like this. So you can already see for a round surface like this is quite nice. Of course, it's gonna like overlap with itself, but we're gonna tell in code that it should only fire when it's colliding with the player. Drag it in a little bit more. Something like this is nice. Right, so I made a little mistake. Right now it's not a child of the cylinder, so if it would rotate, you'll see it actually here right now. The sphere collision would stay in place. We don't want that, so simply just drag the sphere collision and drag it onto your red mesh. If you don't know what a red mesh is, here in the components tab, just click on a red mesh and it will show you. Simple as that. Now with the collision selected, if I scroll all the way down, you see all these events. But the one you use the most is the onComponent begin overlap, and sometimes also the onComponent end overlap, which is basically an event for when something overlaps with this collision, which is exactly what we want. So we're going to click on the plus and it will automatically make an event for us in the event graph. Now this will give you like a lot of pins, we call them parameters, but the one we only really have to focus on, the one you have to focus on most of the time, is just the other actor, which just gives us whatever it has collided with. So we're gonna drag out, and to check if it's a player character, we can simply just do a cast to our character, so third person character. The cast is basically a way to check, hey, is this other actor that, well, the collision just overlapped with, is that our third person character? Is that our player, right? We want to do something only when it's a player. And if so, we can even do something with the player character. As our game grows, these systems need a way to talk to each other, like the player, the obstacles, UI, and that's exactly where Blueprint communication comes in. I've made a couple of other videos about Blueprint communication, so if you want to learn more about it, just check out these videos. But in this video, I'll briefly go over casting and event dispatchers and how you can make different actors communicate with each other. You can, for example, set the actor location like this. You can basically teleport the player. We don't want that. We want to launch the player away. So luckily, there's a node called launch character, which is exactly what we're going to use. But you'll see it needs a launch velocity, which is a vector. And a vector is basically a line. So it just needs a direction to launch into. Right now it would launch technically, but because the X, Y, and Z are all 0, it actually wouldn't really do anything. So how would we know what direction a player is being launched to? Because, well, this thing will keep rotating. So it depends on where the mesh is, right? So how do we know what direction the player should be launched into? Well, you can calculate this in multiple ways. What I usually do is I'm just going to add an arrow here. So in the components tab, press arrow. I can type arrow. There we go. Arrow. And we're going to point this in the right direction. So frontwards. Because we know we always want the player to be launched in the frontwards direction, right? If the player is here, I want it to be launched away from the hammer, right? So we have this arrow. And now there's a very simple node to check what like the frontwards direction is of this arrow. So if we're going to get this arrow, we can simply do get forward vector like this. So we're going to get our arrow and get the forward vector. And before we hook it into the launch velocity, I want a variable to control how fast the player is being launched, just like this variable. I'm just going to do a multiply. And I don't want this to be a vector. I just want it to be a float. So we just right click on the pin. We say to float. And now whenever it's 0, of course, it's not gonna launch, but we can make this a variable by dragging to the other side. We say promote to variable. And we're gonna call this launch force. And I have no idea how big this should be, honestly, but I'm just gonna give it like 100. And now I'm just gonna drag it into the launch velocity. And this should launch our character. So what it does, there's a collision. Whenever it collides with something, it's checking, hey, was this the player I collided with? And if so, it launches the character towards the direction of this arrow. With the launch force, we give it here. We're going to make this instance editable again, so we can easily modify it within our level. And as you can see right now, we have our launch force here. I'm going to click on play. So it's not really doing anything yet. But if I put this like very high, like 1000, okay? You see it's being launched a little bit. But you also see that sometimes it launches a little bit faster than other times. But how is that possible, right? Because it's just one value and it should launches with the same speed every time. Well, that is because there's like this double kind of overlap. So whenever it's overlapping, sometimes it does it twice, and when the overlap happens twice, it will launch a character twice, which will give it twice the amount of force. So you can also test this by either having a print string here, to basically check how often this fires. So it does it once, it does it twice. So there you go. You saw it, it did it twice, and now just once. If I kind of walk against it, it will fire twice, and we don't want that. So we can easily do that by making a cooldown. So just delete the print string. Or before I make that, there's also another debug method. You can click on the event, and then I think it's F9 or F8, and it will create this red bubble. And you'll see what it does. If I play here, it will stop the game, and it will instantly go to this breakpoint. That's what it's called. Right? And with a huge arrow, it will show this is the event that just fired. And with these buttons, you can go to next nodes, and you can, for example, check what this direction is. If you just hover over the line. In our case, it's fine, but if you want to check variables, this is a nice way of knowing that. But in our case, to test if it fires twice, it's probably best to just use a print string. It's easier to check. So we're going to remove this breakpoint. If you do want a video about breakpoints, by the way, let me know in the comments. So let's add a cooldown. So we're going to make a variable. We're going to call it cooldown activated. And we're going to make this a Boolean. So Boolean, you can see it here. If I press set, it's a checkbox. It's either on or off. And when we launch a character, we want to activate a cooldown. And we're going to make a timer. And then after like 0.5 seconds, maybe even a little bit less than that, we're gonna disable our cooldown. So it's a very short cooldown, and how we can make a timer is drag out, and we say set timer by event. I use this node a lot. It's a little bit more reliable than a delay, so I would recommend using timers instead of delays whenever you can. So we say create events, and right now we're gonna make our custom events, right? These are all generated by Unreal Engine, but you can also make our custom event. You can either do it here, and then scroll down to create a matching event, or you can just right click anywhere in the event graph and you say custom event. There you go, add custom event. And we say disable cooldown. Then make sure to assign that event, and it's right here, disable cooldown. And we're gonna drag the cooldown activated. We say set, and we're gonna disable the cooldown. And now the last part, before it's even checking if it's a player, we want to check, hey, are we on a cooldown? So just drag this out a little bit to the right. And another node we use a lot of times is the branch. And if you use coding, this is your if statement. So if Boolean is true, it will do something. If Boolean is false, it will do something. So we want to have this check, and we're going to get the cooldown activated. So get cooldown activated. And only when it's false, it should launch a character. Now what I like to do is, for readability, I like to use the not Boolean. It just reads a little better. So if the cooldown activated is not true, and then you can just ignore this true, right? This basically inverts the Boolean. So right now it will check, is the cooldown not activated, then launch a character. But if it is activated, it will not even do all of this code. Lastly, don't forget to set this time. We can set it to like 0.3. We don't really need a variable for this. And just to test, I'm also gonna get a print string again and see if it still outputs twice. We should be seeing it with our like launch. If a player gets launched really far, you want to check this. And as you can see, it only happens once. So there you go. That's our like first kind of obstacle. I think I'm going to make the launch force a little higher. And again, we can easily do that by going in here and we can set it to like 1250 maybe a little bit higher. What if I just put it on 2000? Yeah, so that's too much. So that's a little design tip. When you change variables, just change it by a lot and then try to find a middle ground. So maybe 1500 is fine. Yeah, I think that's nice. So we're going to remove the print string and that's our first obstacle done. And if you have any questions, make sure to drop them in the comments. I'll try to respond to them as soon as possible. I just want to replace all of these with the actor that we just created. All right, so I replaced all the rotating hammers from our blockout with the actual actors. I think by default, the launch force is still set to 100. I think I set it to like 1500, if I'm not mistaken. So let's set a launch force by default here in the blueprint to like 1500, compile and save. Now these should all be changed to the launch force of 1500. As you can see, it does work. So they all start rotating at the same time, which means that, yeah, it looks like this. We can change that by giving the like rotation a little delay before starting to rotate. Right now you can also just kind of jump over, so probably have to make this a little bit higher, or maybe not, I don't know. So yeah, the last thing I'm gonna make is I'm gonna make this small delay before it actually rotates. So then all the hammers will get a random delay in seconds before starting to rotate. So we're gonna use the event begin play, because at the start we want the delay to activate, right? And what I would usually do is just set a timer like this, and then give this timer like a random float, and then activate this event. But the thing is, you cannot activate an event tick from a timer, unfortunately. So we're gonna have to do this a little bit differently. We're gonna make a variable, we give it the name should rotate, and before it's gonna start rotating, we're gonna check, hey, should it even rotate in the first place? And only when it's true, the actor should rotate. Now on begin play, we're gonna set a timer by event, create events. We're gonna create a matching event. We're gonna say start rotation, I guess, or maybe set rotation to true. And all this really does is we're just gonna get it, should rotate, or no, not get it, should set it to true, because now it can rotate. So I always like to make my events like kind of chronologically ordered. So we're going to start with the begin play, then it's going to set the rotation to true, then it's going to start rotating, and then it overlaps with something. And then we have the overlap logic, then we have the cooldown. So it all makes sense like where I put these events. Now make sure the should rotate is off by default. And then in the set timer by event, we want to give this a random float. So say random float. Now, if we do just a completely random float, it will just give a float between 0 and 1. I want to have a bit more control over that. So we're just going to get a random float in range. And we want to say like between 0 and maybe let's say like 3. Not 3, let's say 3. So what this does is on begin play, it will set a timer between 0 and 3 seconds. Then it will set the should rotate to true. And only when that's true, it should rotate. Easy as that. So let's test it. Now click on play. You see they all start moving at a different time. So that's how you kind of add like a randomness in your game. And now every time I play this game, it makes it interesting because now every time these obstacles are different. They start rotating at a different time. All right, so that's this obstacle fully done. And again, if you do have questions, just let me know in the comments. And if you're stuck with anything, also just ask or just go back in the video. Now, of course, there is this slow platform, and that's what I want to make right now. So just like last time, we're going to open the content drawer in obstacles. We're going to create a blueprint class of type actor. We're going to give it pp_slow platform. Open it. This code is going to be very simple. We're just going to add a box or a cube, I think. There we go. Just static mesh. I'm going to scale this down, scale this like this. And we can always make this bigger or smaller in our own level. And we don't need it to be very thick. And like this will do just fine. We're going to give it like the purple kind of color we gave the slow platform in the first place. So again, I want to detect player collision. So I click on the add in the components tab and I add a box collision. Just name it box, that's fine. Make sure it's parented on the platform itself. We're gonna scale the collision like this. Doesn't need to be very thick. It only needs to detect when a player is like touching the ground. Cool. Something like this should work. And just like last time, we're gonna get the on component begin overlap. Other actor is the third person character. And now, if you take a look in the third person character, it has this character movement component. We talked about this earlier in the video, where you can change a lot of these settings. Now, from a cast to third person character, you can also get this movement component, which is very nice. It should be all the way at the bottom, or get character movement. There you go. So this will get this basically, and you see all the settings, including the max walk speed right here. So we want to set the max walk speed to lower. So we want to set max walk speed, and you can see I can just modify this value from this blueprint, which is really nice. So by default, the walk speed is like 400. So let's say 300. So make sure to also add a on component and overlap event. Because like this, the character will forever be slow. So whenever it's stepped into like the slow platform, it will never walk at the normal speed again. So we click on the collision, then on component and overlap. We want to check if it's the player again. So we can just copy. We can actually just copy all of this like this. There's other actor, do this. And we want to set the max walk speed back to 400. And that should be all. If I now test it, you see the character is now very slow. But if I drag it out a little bit, like this, it's fine, I'll just delete it later. You can kind of bypass it by just jumping. So I think what Fall Guys does is you cannot jump whenever you're on the platform. I also want to prevent the player from being able to jump whenever they are on the platform. So we did take a peek at the third person character before, and we saw it had this jump event. So I'm simply going to make a variable called can character jump. We're going to get it, and only when this is true, it should be able to jump. By default, it should be true, and the only place where I'm going to change this boolean is in a slow platform. So whenever I collide with a box, I'm also just going to get this value from the player character. So we said get can character jump. There we go. Actually, we want to set it. So set can character jump. We want to set it to false. If you double click on a line, you can add this reroute node, which just makes your blueprints a little cleaner. You can reroute them like this. So we also want to make sure that we set this value to be true again. Just do it the same way. We hook this up to the target like this. We add a reroute node like this. Make sure to set this to true again. So now, whenever I am on the platform, I shouldn't be able to jump. I'm spamming spacebar, but nothing happens. And when I'm off the platform, I can jump again. Perfect. So whenever you're on the platform, you're slow and you're not able to jump, which is exactly what we want. Now I'm just going to replace this platform with my newly created beautiful slow platform. All right, something like this should work. So now by default, I can just jump. I have my normal speed, but whenever I'm on this platform, I cannot jump and I'm slow. So that's just a very simple way of making the character slow. So to recap, what we did is we made this collision box in our components tab, and we're checking if something overlaps. Hey, was it our player? Then from our player, we can get our character movement, with which we modified our max walk speed. And we told the character to not be able to jump, to just disable this Boolean variable that we created in the third person character, like here. So whenever I try to jump, this event fires and the character blueprint has this if statement. And if this Boolean is false, which we set here, it will not do the jump. And I'm basically inverting everything I did here whenever the player is not on the platform anymore. Oh yeah, here I also have a slow platform. I'm just going to delete it and just insert the slow platform under obstacles, slow platform. Cool. So next up, I want to make these rotating like circular platforms. So again, we're going to start with opening the content browser. You can do that using Control Space, right click, blueprint class, actor. We're going to call this BP underscore rotating platform, I guess. Open it. We're going to make sure to make our meshes here. We're going to start with a I think like a cylinder, we're gonna scale down a lot. All right, we're gonna add the material and kind of see where the middle is. There you go. So exactly on this middle point, I want to add another small cylinder. Now I want to implement the kind of like huge stick that rotates, which is just going to be a cube like this. Give it the red material to indicate danger. And the setup will be very similar to the rotating hammer, where we had this collision box with an arrow going out of it. We're going to do the same here. So we're going to add a cube collision, or a box collision, I think it's called. There we go. So we're going to have two, because here we want the collision to happen here, and here we want to have the collision here. So there's two collisions. Just scale it up, maybe not this much, just so it covers kind of the length of this part of the stick. I think that's fine. Now you see this collision is a child of the bigger stick, so that's exactly what we want. We also want that to happen with the other stick, so make sure that the stick is selected and not this collision box. Otherwise it's going to be a child of the collision box. We don't want that. On the cube, make sure to add and give it a box collision. Now you see it has two children. It has one collision and the second collision, which is right here. There we go, something like this. All right, we have our mesh, we have our collisions. Let's make the rotating part work again. And I'm going to use the exact same method. So for now, I'm just going to remove the begin play and actor begin overlap. I think we're going to use the begin play later on, but for now, I'm going to delete them to make some space. So I want to set add actor local rotation. We're going to right click, split struct pin, and we want to rotate it on the z-axis. Just check, I'm going to give it the value of 10 for now. I'm going to place one in the level. Also see it's way too small. So we probably should scale this up by a lot more. We can do that here in the default scene routes. Just scale this up by a lot more. It's still too small, about like 5. Yeah, it's getting there. Maybe 6. See, and this is why we made a block at first, so we can kind of see the scale of the of these obstacles. It's a bit hard to see it in a blueprint editor, how big they should be. I think this is nice. A bit too big, so maybe 6.5. Still a little big, but I think it's fine. I'm also going to make these sticks like a lot thinner, because with scaling it up, the sticks also became way too big. And as you can see, the collisions, because they're parented, they will also scale with scaling the stick. So it makes scaling a lot easier. All right, now we've kind of mimicked the size of the original obstacle. I just want to test it. Now we have the event tick functionality set up. So you see it spins, but it's a little bit fast. So in the event graph, we're going to make a variable called spinning speed, which is going to be a float. And we multiply that with our delta seconds to go into the delta z rotation, compile, and give it a default value of like 1000. Now when I play, it spins still very fast. Decrease this to like 500. Also make this instance editable, so we can easily adjust the variable in the level. It's still going a bit fast, so we're gonna make it like 200. I think this is pretty difficult, but you'll see one of the issues, and it's that the floor is also spinning, which is not what we want, because we just want this stick to rotate. So we can easily change that, but we need a different node for it. So we want this cube to rotate, but as you can see, you cannot drag it in because this is a component and it's not the actual actor itself. And it looks for an actor and not one of these components. So luckily there's a node for it. If you just drag out of the cube, say rotate stick, just so we know that this is the thing we need to rotate. And just search for rotate, add rotation, add local rotation. There we go. And then split the struct bin, move this in here, move that in here. Now it does the exact same as before, but now only the stick rotates and nothing else. So this doesn't rotate, the floor doesn't rotate, just this stick. Awesome. So just like the rotating hammer, I'm going to give arrows to the collisions. This time I'm going to parent them to the collision boxes themselves, so they always stay in the same location and rotation as these sticks. So add, give it an arrow like this. And you see that the transform settings kind of copied over from like all these scaling settings. So how we can change that is quickly just drag this onto the cylinder, so onto the root of our blueprint. Doesn't really matter, by the way, because we're only checking for direction and not like the length or anything. But because this looks a little bit weird, I'm just gonna fix this real quick. I think this is fine. And when you're happy with it, you can just drag it onto the box again. Now you see the scaling settings have changed a lot, and that is fine. I think I can just Ctrl+C and Ctrl+V it on this box. There we go. Rotate it like this. Now you see the arrows move with the obstacle. But we are running into a little bit of an issue. You might have figured when I was making 2 of these collision boxes, in the rotating hammer we just had 1. And we just check for one of the arrows, get the forward vector. But now we have 2, so how do we do that? Of course, what you can do is on both of the collision boxes, scroll down, on component begin overlap, and do the same for this one. And then you're just gonna make the overlap code. So you're gonna check for the player. You would get the forward vector, and then launch a player with like a force to that direction, right? And we would have to copy and paste this here. Now this would work, but you see it as like repetition, right? But you see we are using like double code. We have to copy and paste it. There's a slightly more efficient way. If you don't want to do that, that's fine. This would totally work. Let's actually just test it right now. And make sure to like replace arrow 1 with the other arrow like this. I'm just gonna set the spinning speed a little bit lower and make this a force. Launch force, like let's say 500, which is also going to be dragged in here. You see it launches me, so it does work. Same for this one, in the right direction. Always looks at the frontward direction. Probably can use a bit more launch force. But what I wanted to show you guys is that we can do this more efficiently. So on begin play, event begin play, that's why we're gonna add this event again. We're gonna make an array of these 2 collisions. So an array is basically a container that contains multiple variables. So I'll show you. So you can make array, or probably drag this into the event graph first and then make array, add pin, there you go. So now these 2 are listed in kind of a container. They're stored. Now we can look through both of these components with a for each loop. So if you hold F and click, you'll see the for each loop, or you can right click and say for each loop. There you go. You're gonna drag this array in here, put event begin play in there. And now I'm gonna make my own custom event for checking collisions. So basically what we're doing here, but then 1 event instead of 2. So we can do that by binding to on component begin overlap. So this is an event dispatcher, which is stored in this components code. I've made a video about event dispatchers, but it's basically whenever one of the colliders overlaps, it will give a signal to any blueprint that is bound to this on component begin overlap. So it's basically communication between code. So I can show you if I create an event here, which is just custom event, actually create event. I'm gonna make an event. We say on component begin overlap. You see, it's basically the same parameters as these 2, right? But now it's just 1 event. But one big difference is that it doesn't have this box1 or box behind it. And that's because this event belongs to only this collision, right? This one. Well, the other event, this one only belongs to this one. And with this event, it's kind of like a global event. So whenever one of the collisions collide with our player, we can check which collision overlapped with it. So it's this one, the overlapped component. And for now, I'm just gonna get a display name and print it out. It will show us which of these it collided with. We also only want this to show when it overlapped with a player. So we want to call to the 3rd person character. Drag this in here, compile save. For now, I'm just gonna disable these, right? So these events are not doing anything right now. So on begin play, we make an array of the 2 colliders. Then it's going through each of these colliders and bind it to on component begin overlap. And if something overlaps, it will fire off this event. And for now, all we are doing is we're checking if it's a player, like usual, and we're checking which of these 2 we're colliding with. So we press and play, you collide with 1, and you see box 1, just a box, box 1, just a box, right? So why do we want to know which of these colliders we're overlapping with? Well, because we want to know which of these arrows we have to use, right? Because if we collide with this one, we don't want the player to launch in a direction of this arrow. We only want the player to launch to this direction. So we know it detects the right collision. So what we're now going to do is, out of the overlapped component, we're going to get the child component, I think. Yes. And the child component, as you can see, it's this arrow. So that's how we're going to get this arrow. We only have one child component, so we can just use this node. If you have multiple child components, make sure to assign the correct component in here in the child index. For example, just make sure that the arrow is always at the top of your list. And then you can just put in child index 0. With this, we're going to get the forward vector. And we're going to launch the player, launch character with this launch force. There we go. So as you can see, it's literally just the same code. Well, we're using getChildComponent instead of the arrow variable, but we now only have one event instead of two events. So let's test it out. We are seeing we are being launched a little bit. I am going to make the launch a little bit heavier. So again, make this instance editable, compile, save, launch force, maybe give it like 1,000. Let's play. There you go. This one works fine. Launches me in the correct direction. And this one does as well. Trying to not die. There we go. So that works. So if we stand all the way on the edge, it will. So yeah, to recap, you can use these two events if you want. In that case, it's literally just the same code as the rotating hammer. But because we have more than one collider now, I made these into an array, which we're binding to on component begin overlap. So when anything overlaps with one of these boxes, it will fire this event. And so that means that we kind of combined these two events into one, which makes our code a bit cleaner. And then we using this overlapped component, which is our like box, right? Our box collider. We get a child component of the box collider, which is the arrow, gets a forward vector, and then it launches the character with the launch force. Now, this last part was a little more advanced. So if you like to just use these two events, you're free to do so. It literally does the same. This is just a little bit cleaner. You can imagine if you have a lot of collisions that you would have to implement a lot of events. Well, you can do it with one event as well using this system. All right, I replaced old platforms with the new ones. As you can see, we now have a new obstacle in our level, which does work really well. Now, next up are these rotating propellers. And if you understand the implementation of these circular platforms that we just made, these ones are going to be the exact same. So we're going to make a new obstacle by going to our content drawer, right click, blueprint class, our actor, BP underscore rotating propeller. We're going to make a mesh, which is literally just two cubes. Now, before I continue making any implementation and parenting the components, I just want to check the scale. So we need to make it a lot bigger. All right, so something like this. Then I'm going to make collisions. It's going to rotate clockwise again. But now we need 4 collision boxes. So we went from 1 in the rotating hammer to 2 in the rotating platform to now 4 in the rotating propeller. Because all of these sides, they need a collision. So we're going to add a cube collision or box collision. Make sure to scale it properly. Then we're going to copy and paste it. We're going to put this on the other side. So here. All right, these collisions are now set up. Now we just need 2 collisions for this side and this side. So the trick I'm using, I'm just copying and then I'm pasting on the cube. For some reason, it doesn't set it on the cube. So it scales very weirdly. Just dragging it on the cube. It's still scaled very weird. So then I'm just going to one of these, right click on the scale, copy, and then paste it in the scale of this one. And now it has scale. Place this here, and then also drag it on the cube, paste the scale, and that is the last one. Now we're going to work with arrows again. So under each of these collisions, we're going to add an arrow. So the arrow is probably weirdly scaled again. It is. So I'm just going to attach it to the default scene root, which doesn't have any scaling. I'm going to reset the scaling and drag it into box 2 again. And now it has the normal scale. Let's see, what is box 2 again? It is this one that rotated 180 degrees. So again, the placement doesn't really matter as long as it's just at the same direction as the box collision and that it's a child of the box collision itself. Otherwise, it won't move the whole thing. We're gonna do the same for this one. So copy, paste it in, box 3. And now we can just copy this scaling and paste it on this one, which will make it our normal sized arrow. We're gonna do the same for this one. There you go. Now we have all the arrows, all the collisions set up. So let's get into the event graph. Now we're gonna just use the same setup again. On begin play, we're gonna make an array using all these boxes. Just drag them in, get box. You can also just get them from here actually. It's a bit easier. Box 1, get these out of the way for now. Box 2 and box 3, we're gonna make an array. 4 pins, 1, 2, 3. For each loop, so F and click, shortcut. On begin play, I'm gonna bind. So on the component begin overlap. I'm gonna create events, create a matching event on begin overlap. Then we want to cast to the third person character. You'll notice I'm making the on begin overlap functionality first, instead of making the rotation functionality first, which we do on event tick. Doesn't really matter what order you do it. For now, I just want to show you that this is also possible to first create this functionality and then the rotation part. So again, we want to launch our character. What direction do we want to launch him into? Well, that depends on which arrow. So we need to get the child component. So again, it's just one child component of the box collision. We get the force vector. We multiply it by a variable called launch force. And you just notice that we are doing a lot of things just literally the same way. And that is perfectly fine. We know it works. So this launch force, we're gonna make it instance editable. For now, give it like a value of 500. Probably will change it later. This vector will go into the launch character. And that's it. Now when I make some space, I'm just gonna drag it into here. It's not gonna rotate, I know. I just wanna test if the overlap works. And you see it's kind of jittering. That's probably because the launch force is too low. Say not 200, 2000. Gonna play. There you go. Launches us into the right direction. Same with this one. Same with this one. And same with this one. Now let's make the rotating part work. Really easy. On tick. And again, guys, tick is a bit of an iffy event. For this, it's fine because making a mesh rotate doesn't cost a lot of performance. But for example, when you load in things on tick, then you're gonna notice that on performance. Actually, I'm gonna make this without tick, just to show you guys. In that case, we're gonna make an event or a timer. So set timer by event, which I will set on every 0.1 second. I'm gonna create events. We say rotate object, I guess. And now you see that because this is 0.1 seconds, it will call it 10 times per second, which is lower than the usual like 60 times per second. Or set actor local rotation. Actor relative rotation. We're gonna split this. And for now, I'm just gonna give this like 10. And if I now press on play, doesn't quite work because it only happens once. We wanna set this on looping. Little mistake by me. And it still doesn't do it. Okay. All right. We want to add the relative location. So add actor relative vector local rotation, split struct pin, give it 10. And you see it definitely moves. It's just a little choppy. So it is more performant, but let's say we want to put 0.02. It's probably going to spin really fast now. Yeah. But hey, at least it spins. And we, of course, can set this lower, like 2. And now it spins as well. This is if you don't want to use tick, right? But as I said, okay, the launch force is a bit big. As I said, the event tick isn't that big of a deal if you're doing low performing things like rotating an object, for example. But for the sake of showing something different than tick, I'm just setting it on a timer right now. So we, of course, don't have the delta seconds here. We can, of course, change this time, like how often this event fires, but I'm not going to do it. I'm just going to create a float called spinning speed and directly hook that into the delta rotation Z. So it's editable. You might have noticed if you press this, it will also show this eyeball. So this will also just toggle instance editable if you find that easier. I'm gonna set this to 2. And there you go. Make the launch force a little less big, like 1500 maybe. You do see it's kind of choppy. Not sure if you can see it on the video. It's a little bit less smooth than Eventic, but it is a little more performant because it's not doing this every frame. Instead, it's just like a timer. I'm also noticing that sometimes it still double fires. So if you remember correctly from our first obstacle we made, we need to make a cooldown. So we're gonna make a boolean, cooldown activated, make a boolean, then here the launch code, we want to check if we're not on a cooldown, so the not boolean, remember? And only in that case, we should launch. Of course, we need to set our cooldown activated here. So we say drag this in, we set this to true, and then we're gonna make an event. It is literally the same thing as we did here, right? Set cooldown activated, make an event, and then here, set cooldown activated to false again. So we're gonna make a timer, and after about 0.3 seconds, create this event. We're gonna call this disable cooldown. And all we're doing is we're setting the cooldown to be false. There we go. So let's test it. Even if we walk against it, it will never launches very far. It will only ever be triggered once. Perfect. So notice how if you would have implemented events for all these collisions, there would have been 4 of these events literally doing the same thing, right? And again, it would work. It just would make your event graph a lot more messy than it is now. Because right now we just have one single event. Now, when anything collides with any of these boxes, these box collisions, it will fire this event and look which box collision has been collided with. So that's another one done. Let's first, by the way, give it the material. Because this rotates, I think I made it like a blue grid. Now I'm just gonna replace all of the ones we had here with our new actor. So something like this. So if we now press play, you see it becomes a little difficult already. So far we have these rotating propellers, we have these circular platforms, we have the slow down platform, and finally we have the rotating hammers. But now we're actually going to make these sideways moving obstacles. So instead of them rotating, they go from left to right. And additionally, when the player walks against one of these obstacles, it will bounce backwards. If the player walks against it from this direction, they will be bounced this way. So it's going to be a little more advanced, but if you've been able to follow along with the other obstacles, then they should still be very doable. All right, let's get into it. We go to the content drawer. We're still in the obstacles folder. You right click, blueprint class, actor, called BP underscore sideways moving obstacle. And as always, we're going to start with making the mesh. It's a very simple shape again. It's just a cylinder. I'm going to scale this up a little bit. And I'm going to give it the material. I'm also just going to place it in the level straight away, just to see the scaling. And it's pretty good. We can size it up a little bit more, I think. On the z-axis, I think the x and y are fine. So go back into a blueprint. Make sure this lock is off. And then we scale it a bit more on the z-axis. And when you then compile, you go back into the level, it has now changed the dimensions. In this case, the z dimension. It's a little bit bigger, but it doesn't matter. So we have to make this obstacle move somehow from left to right. And there's actually a pretty easy way to do that. And I'll show you. What I'm first going to do, delete these 2 events. We're not going to use event tick this time. And we're also not going to use the event actor begin overlap. What we will need, by the way, go back to the viewport, we do need a collision box around the mesh. I am going to make a cylinder or a capsule collision. I think that's the closest to a cylinder. Scale this up like this, it's fine. Don't want to make it too big, otherwise the player is standing like here and there's a detection going on, they get bounced. Doesn't make a lot of sense. So in essence, there's 2 parts of making this obstacle. Number 1 is making the obstacle move, and number 2 is detecting collision and making sure the player is bound to the right direction. So let's start with number 1, making the obstacle move sideways. So we can do that by using a timeline. So just drag out and we say add timeline. And a timeline basically makes a number go up and down with basically the value that you want to give it. And it goes up and down over time. So you can basically see it as like an animation of numbers. So I'm going to open this, Just to give you an example, we click on the track button, add float track. This is what I'm always using, to be honest. We just say number. And this is basically a graph. So the x-axis is the time and the y-axis is the value. So if you right click anywhere, doesn't really matter. You say add key. Then here you have time and value. So for now, let's say 0 and we say 0. So it's, oh, there we go, 0. So now it's on the 0, 0 point. So 0 on time is 0 on the value. Right click somewhere else, add key. Let's say we want this on 2 seconds and we want this to be like 50. Now you can kind of see a line here. If you just press these buttons, it will just zoom to fit. You can kind of see it as it's a graph, right? You can also select them both, right click, and have some nice easing to it. And for now, what I'm going to do is I'm just going to print out this number. So print string. And we want to put this on the update output. We don't want this to be a duration. We just want this to be the thing that it prints. So what should happen is on begin play, this timeline will execute that makes a number go from 0 to 50 over 2 seconds, right? And it prints it out. So let's see if it works. We have the blueprint placed in our level. And you see it indeed goes up pretty fast. Over 2 seconds, it goes to 50. So maybe if you just say, we just thought this to be like 10, and we play, you see there's a number going from 0 to 10 over 2 seconds. This is kind of like the foundation how we're going to move our obstacle. We're going to make a number go up and down, and we just make sure that it loops that. So 9 out of 10 times I use a timeline in combination with a lerp. And I'm going to show you what it is. I'm going to delete this print string. And we say lerp. For now, this one is fine. And I'm going to drag this number into the alpha. And you see we have an A and a B value. So what this basically means is it will take this alpha, which needs to go from 0 to 1. So let's do that real quick. So right now the value is 10. Let's put that to 1. Now it goes from 0 to 1 over 2 seconds. And then it will blend between the value here in A and the value in B. So when this has reached 1, that's when this output pin outputs the B value. But when this timeline value is at 0, it will output the value here at A. So to show you in practice, let's set the value of A to like 5. And let's set the value of B to 6. And then we're just going to print string, put this in the string, update. And if I now play, you see in the top left corner that it went from 5 to 6, right? So it was blending between the A and the B value based on like this graph. Could also make this a lot longer. So over 10 seconds, it's going to blend between A and the B value. Compile save. And you see it goes from 5 to 6, but a lot slower. So we actually forgot to change one part. So the timeline has a length. You can see here 5 seconds, and it will just cut off there. So let's just make that 10 seconds to align it with our value time of 10. So yeah, now it does go past 5.5 and slowly crawl its way to 6. Now, what we can also do is just put this time to 5 and put another point in here and say time is 10 seconds. The value is 0. So this is how the graph looks. On 0 seconds, the value is 0. On 5 seconds, the value is 1. And on 10 seconds, the value is 0 again. So what should happen is you start at 5. After 5 seconds, the value should be 6. And then after 10 seconds, it should be 5 again. So let's test it out. You play, it goes from 5 to 5.5 to 6, and it goes down again to 5, ends at 5. And you can easily make it loop by ticking this loop icon. So if we now go to our level and test it out again, it goes from 5 to 6, and then it goes back to 5 again, and it goes back to 6. So now it's just gonna continuously loop. So now we made a number, a float, go from 5 to 6, from 6 to 5, and from 5 to 6 again, on repeat. Now, instead of that number going up and down, we want this obstacle to go left, right, left, right. How we do that is we're not going to use floats, but we're going to use vectors. I've used vectors in other obstacles already. Now we're basically going to say, okay, this obstacle, it's right here. I want you to move here, and then I want you to move back again. with the same logic, the same timeline, just using vectors instead of a float. So I'm going to show you how that works. So before I'm doing all this timeline shenanigans, I'm just going to delete the print string and the lerp. I'm going to keep the timeline. I will just get the actor location. So on begin play, I'm going to get the world location of where the actor is placed. So in this case, it's right here. So these variables. And I'm going to save that to a variable. I'm going to call it like begin location. Hook this into the play of the timeline. And I'm also going to need a move offset, which is also going to be a vector. When that's done, we're just going to get this begin location, and this begin location will be like the A value that we just had. When we went from 5 to 6, 6 to 5, this would be like our 5 value, right? Then out of the number, we're gonna say lerp instead of a float lerp. I think there's something like a vector lerp. There we go. And the A value, as I said, it will be the begin location. Now the B value will be the begin location plus the move offset we're gonna give it. So we say plus, we drag this into here, and then this is going to be our B value. So something like this. So compile, save. And finally, we're going to say set the actor relative location, and we plug this into the update. So if you take a look, we need to adjust the y-axis. You see, if I move it to the left, the y value goes up. If I move to the right, the y value goes down. This is a little mistake on my part. I probably should have built the level that way instead of that way. You can also see the x-axis is point backwards. Doesn't really matter. We can just either place this on the left and make the move offset a negative y value, or just start it on the right and just go left to right. Let's just put it on the left and make the y value, the move offset, a negative number. Let's say this should be like minus 200. I think if I now start playing it, you see it moves. Kind of looks like it's rotating, so that's like an illusion because of the material. But in fact, it is not rotating. It's only just moving from left to right. Honestly, with like the easing and now it's flying, it kind of looks like a sci-fi kind of thing. Something you would find in a spaceship. Right, but anyway, we need to adjust this a little bit more. Maybe let's say double. As always, I'm going to make this move offset an instance editable, so I can easily adjust it here. I'm going to say minus 400, playing the level. There we go. It is moving. However, it's going a little bit slow. This wouldn't really be a challenge. Now, what you can do to make this timeline faster is before we do the timeline, you see we have this timeline variable under our components tab. So if we drag that in and we say set play rate, we can basically determine how fast this timeline should run. So I think if it's 0, the timeline will just not do anything. If it's 1, it's your default speed. So I want it faster. So let's say I want to give it like 3. Compile and let's test it out. And you see it moves a lot quicker now. Very nice. I think the speed is pretty good actually. Lastly, I am going to make this a variable called move speed. And again, I'm going to make this instance editable by either checking this checkbox or by pressing the I under here. And now we should see it in the details panel. So we have the move offset that we can determine, and we have the move speed that we can determine. Cool, so that's step 1 out of 2 done for this obstacle, making it move. Now step 2 will be detecting collision and making sure the player is bounced into the right direction. In the previous obstacles, I could simply just add an arrow to the blueprint and then just send the player in the direction of that arrow. But that doesn't really work right now because we want the player to be bounced away from the cylinder, right? Away from the obstacle. So arrows wouldn't really work. We want a way to detect where the player is hitting this obstacle and then push the player away from it. So how we're going to do this is quite simple. We're going to get the player location and we're going to get the actor location, so just the location of this obstacle. And then we're subtracting the actor location, so this obstacle location data, from the player location data. That way we do know what direction the player is in relation to the obstacle. So it looks like this. We're going to get the player character. We're going to get the actor location. And then we're just going to get the actor location of this actor. So of self. And we're going to subtract it. And then there's one more thing that we need to do. And that is normalize this vector. We can actually use a normalize 2D because we don't care about the z-axis. So a normalize is basically, you can basically see a vector as a line. So it has a length and it has like a direction that it points to. So a line has a length and a direction. So with a normalize, you're basically saying ignore the whole length part. We only care about the direction because we don't really care how far the player is from the obstacle. We'll just have this collision detection. The only thing we care is where is the player standing as opposed to the obstacle. So that's why we're using the normalized 2D. If you don't do this, you get like a really big vector value because it also takes into account the length, like how far the player is from the obstacle. We're gonna make this a variable called movement direction. If you don't fully get this part, by the way, that's totally fine. It is a bit complicated. I would just recommend try to work with vectors more, try to do some research about it, or just let me know if you want me to make a video about it. I can also make a tutorial about vectors, because vectors, they are kind of complicated, but they are super useful. For these obstacles, we've been using them so many times. So on begin play, we're setting the begin location of our actor. So that's our obstacle. Then we're setting the speed of our timeline. Then we play our timeline, which basically goes from 1 to 0. And then we blend between the begin location that we set here and the move offset. This part makes the obstacle move from left to right. Then still on this update execution pin, which by the way, keeps updating whenever the timeline is also like playing, whenever it's updating. We want to check what direction we want to send the player into when they collide with the obstacle. So that's why we have this code. We subtract the actor location, so the obstacle location, from the actor location. That gives us a value. We normalize that value, and that is the direction we want to send the player into. So we have the moving part, we have the calculation part, and then finally we need a way to check whenever the player has hit the obstacle. So as you might remember, we made this capsule component, and we want to have a on-component begin overlap, as we've done before. We want to check, did we collide with the player? So we cast a third-person character, and if so, we want to launch the character. Now we're gonna get this movement direction, or not set it, we're gonna get it. And we're gonna multiply this by like a force that we want to give it. So we make this a float, and we make this a variable called launch force. And we're gonna make this a instance editable variable. We're gonna plug this into the launch velocity. So again, this movement direction we got here, we calculated whenever the timeline updates, just so we know in what direction we want to bounce the player, which is always away from the obstacle. So I think, I'm not sure if this should be a positive or a negative value. I think positive. Let's just try like a really high number, like 1,000. I think if I now just play it and I bounce against this guy, exactly, it will launch me back. Also up a bit because the obstacle is higher than me. So maybe, of course, we did say, okay, we want this to be a 2D vector, but we have this like kind of slope. Maybe we do need it in 3D. So just a normal vector. So normalize, or normal normalize, I have to say. A normal normalize, there we go. I think now it will also push me down a little bit. There we go. And the character will just stay grounded because it also takes into account the Z axis. Every time you hit it, it will kind of bounce you. The bounce can be a lot stronger, I feel like. Yeah, I think it's quite nice. So I think what Fall Guys also does is it will also bounce the player backwards a little bit, just to add a bit of challenge. So how we're doing that is quite simple. We just need to like add another vector to this. So now we can actually use an arrow, which I'm gonna do. So on the cylinder, I'm gonna add a component called an arrow, something like this. I'm gonna get the arrow, I'm gonna get the forward vector, and I'm gonna multiply this by another float, which we're gonna call something like backwards force. This should be a float. We're also gonna make it instance editable by clicking on the eye, and we're gonna plug this into the multiply. And then lastly, we're just gonna add it to our already existing launch force. And then that will go into the launch velocity. I'm gonna give this like a default value, compile save, of like, let's say 1,000. Might be way too big, but we'll find out. So what's gonna happen is this movement direction that we've calculated above will be multiplied with the launch force. And on top of that, we also have our arrow, which is just here. It will get the forward vector. So that way, and it's going to multiply that by our backwards force, our variable that we can tweak. Compile, save, play. And if I now bounce against it, it will, as you can see, bounce me a lot more to the back. I'm going to make this value a lot smaller. Still quite rough, but yeah, maybe the launch force needs to be a bit smaller. Maybe not. Maybe it is nice for a challenge, but that's for you to decide. Maybe I'm going to make it a bit more like 800. It's really like sending me back whenever I collide with it. And I think that's our next obstacle done. I am going to clean this up a little bit more. Instead of having everything on begin play, I'm going to disconnect the timeline. I'm going to make a custom event by just right-clicking and add a custom event. And I'm going to call this a move obstacle. I'm going to drag all of this into this timeline, or into this event rather. And finally, I'm going to call move obstacle. I usually try to avoid like a huge snake of one event, especially on begin play, because usually there's a lot of nodes that need to go into begin play, so it's nice to split it up into functions and events. If you want to know more about events, functions, how to clean your blueprint, make sure to watch one of my earlier videos. So the final thing we have to do is actually not a final thing, because I also do want to like randomize when they start moving, like we did with the other obstacle. But for now, let's replace them all. All right, I placed all the obstacles. You also see I have these opposing obstacles that will just move to the middle and back. But you see it's like very static, so I'm gonna add some randomness. Oh my god. So this is also possible. So we should probably make sure the player cannot get hit above the obstacle. So just move the obstacle a bit down, like this. And make sure that you shrink it a little, like this. So yeah, we're gonna make some randomness as well. So in the move obstacle, we just want to have like a delay. So instead of calling this move obstacle, I'm just gonna make a set timer by events. I'm gonna create the event of move obstacle. And then the time, we just give it like a random float in range between 0 and 3 seconds. So it will take between 0 and 3 seconds before an obstacle moves. I also think it would be cool to have some randomness in the speed, which we can set here. So we're gonna give this same random floating range. Let's say between like 2.5 and 3.5. If you want, you can make these variables. So if I start playing now, you see some activate already. Some will wait a little bit. Some are faster, some are a bit slower. And it just creates this kind of like random feeling to it. We also need the like slowdown platform, which we already made. We get our slowdown platform, drag it in, place it, scale it up. All right, we have our slowdown platform placed. So we now stand on it. We are a lot slower, we cannot jump. And it's already pretty difficult. All right, that's obstacle 5 of the list. And the next obstacle is right in front of us. It's these swinging balls. And for these swinging balls, again, there's going to be 2 steps. Making it like move, just making it swing like this. And step 2 will be the code to determine where to send the player to when it hits this ball. And we're kind of going to do it in a similar way as last obstacle, but not quite. And I'll show you why. So first of all, we're going to create our obstacle. Blueprint class, actor, BP underscore swinging ball. I'm going to recreate the actor. So start with like a cube. Make this really thin and long. So now this stick is kind of the same scale as our block out. Then we're going to add a sphere. We're going to scale it up by quite a lot. Like something like this is fine. Let's compare it. Yeah, that's about right. Can be a little bit smaller. 10. Yeah. Make sure to give it the appropriate material. So for this one, it's just a prototype grid. And for this one, it's the red one. Like this. And we basically mimicked the shape and the colors. Then on the sphere, we're going to add a sphere collision. Make sure it's kind of around the sphere, something like this. Don't extend it too big. Now we're going to rotate one of these components, right? But you see, if I do that, it doesn't really work like that. We kind of need a pivot point. So that's what I'm quickly going to make. So I'm going to create a pivot point, and maybe this is a cursed way, but I'm just going to create a cube, drag it up, scale it down by a lot. So it's probably just not visible. I think that's best. And now I'm going to drag the original cube, so this stick, onto cube 1. the cube that we just created. And now if we just rotate cube 1, you'll see we have this effect, exactly what we want, because it's now kind of like pivoting around the cube that we just placed. All right, so we have everything set up. Then we go to the event graph. We're not going to use begin overlap or tick. We are going to use the begin play event. So yeah, I'm going to use the timeline again. So the timeline will just be a float timeline, not a vector one. So it will just modify the rotation value. It goes from 0 to 90, 90 to minus 90, and then yeah, it will just go from 90 to like minus 90. So on begin play, we're going to add a timeline. We're going to create a flow track. We're going to name this alpha. So whatever you name this track, it will be the output name of your timeline. Then we're just going to have a value on 0, 0, a value on 0, 1. Because remember, the alpha always needs to go from 0 to 1 and never higher or lower. And then finally, 1 on 2 seconds and 0. It might be a little bit quick, but we can always set the play rate of the timeline. I'm going to add some easing to this. So just select them all, right click, and we say break. And this will go into a lerp. There's a normal float lerp from minus 90 to 90. So I'm going to rename this point to pivot, just to not get confused. And I'm going to drag in the pivot. I'm going to say set relative rotation. And we're going to split this struct bin to make it 3 floats. So we can individually adjust the, let's see, what is it exactly? It should be the X value. This will go into the X. And then we just want to update this. You could also make it start like sideways and then it goes from like 180 to 0. Doesn't really matter. I'm just going to do it like this. So let's start test it. And there you go. I forgot to set it on looping. So make sure that is sticked on. There you go. Oh, right. We also forget in the timeline to adjust the length. So we're going to set that to 2 seconds. And now it should seamlessly loop. There you go. This is going a bit fast. We can change that using the set play rate node that we just used. So let's actually do that right now. We're going to get the timeline from the components tab. We're going to set play rate. We're going to make this a variable called move speed. And by default, I want it to be a bit slower. Let's say like 0.5. Oh yeah, and make sure this is instance editable. And it moves a lot slower. And for now, this is fine. We can always tweak it later. All right. So basically the same system as this one, but instead of using a vector and a vector begin location and like a move offset, we're now just hard coding it to go from 90 to minus 90 on the x-axis. Now for the second part of this obstacle, knowing where to launch a player towards. So to determine where to launch a player, I'm not really going to care where the player is at that point. I'm just going to calculate the direction of where the ball moves towards, and I'm going to launch a player in that direction. Where with this obstacle, I needed to check from which direction the player was coming from. So that's why we're doing it a bit differently here. Because this ball will just launch a player to whatever direction this ball will go towards. So we know that on this timeline, it basically updates whenever it has moved the ball. How I'm going to calculate the movement direction of the obstacle is I'm going to compare 2 vectors. The current location of the vector and the previous location of the vector. And the difference between those, that is the movement direction of the ball. So I'm going to make 2 variables called previous location and current location. Both should be vectors. Then on begin play, I'm going to set the previous location, actually, not the current location. I'll show you why in a bit. So we're just going to set it. We're going to set it to the sphere and then get actor location or get location or get world location because it's a component and not an actor. So on begin play, before we even doing this timeline, it saves the location of where the ball is in the world. Then I'm going to set the current location after the timeline. So it's doing the rotation, it's doing the moving part. I'm literally going to do the same thing. So we get a sphere, we get a world location. We set that as the current location. And now what we have to do is subtracting this current location from the previous location and then normalize that, because again, we only care about the direction the player is getting launched into and not like how far the player should get launched. So we're gonna make another vector called movement direction. We're gonna set the movement direction, and we're gonna calculate it by getting the current location and getting the previous location, subtracting those from each other, and then finally normalizing that vector, plug it into the movement direction, and there you go. That's how we calculate our movement direction. That's how we know what way the bow is moving. And then finally, to like update the previous location, we're gonna set the previous location and we're gonna put in the current location. And then it starts over again. So we've updated the previous location. Then while it moves, it sets the current location. So at this point, it has moved a little bit further. And then it's subtracting the current location and the previous location to get the movement direction. So it does this a lot of times, right? Every time it is moved, even if it has moved just a little bit, it will calculate the movement direction by subtracting the current location and the previous location. These values are being updated constantly, basically, throughout our game. All right, so the obstacle moves. We calculated the movement direction. The only thing that's left is to make the overlap logic. It's just the same logic as we've used for all the other obstacles, basically. We're going to cast to the third-person character, and then we're going to launch the character. For this, it's just super easy. Movement direction times a float. We're going to promote it to a variable called launch, force, make it instance editable. We're going to give it like 1000. And I think that should be all. So let's test it out. It doesn't quite work yet, I think. Right, I think I'm not being launched far enough. So I'm kind of like clipping into the ball. So I get launched. That is very far. Let's calm down a little bit. 2000. Still launching me very far. 1500. I think that might be fine. Whatever, just stand on the ground. It doesn't even hit me. Okay, I should probably put this a little bit lower so it can hit me when I'm just standing on the ground. It's not really... Okay, there you go. But again, to clean this up a bit, I'm gonna move this down. I'm gonna make like a custom event and call it move obstacle. Again, there's like so much repetition making all these obstacles, right? But once you get a hang of it, it's so easy. You can basically make any obstacle you can imagine. And the last thing I'll add is add some randomness. So we're gonna set a timer by event, call these events. This is move obstacle. We're gonna call it after a random amount of seconds. So we're gonna say random float in range. Between 0 and 3 is fine again. Maybe 0 and 2. Doesn't need to be that big. Same for this one. So the default value we give it is 0.5. So let's say it's random float in range. So like between 0.2 and 0.7. Let's do 0.3. So 0.5 is in the middle. So you do kind of see it like clipping. So if I just put this a bit higher, like 10, 103, or maybe 5. So it starts out vertically and then it snaps to the starting position. So I think what I'm going to try to do is just make this start rotated already. So on 90, I hope this works. 0 to 180. Actually, we don't need to change these values. Right, there we go. So we had to rotate the pivot on the x-axis by like 90 degrees, minus 90 degrees in my case, and then just keep these values the same. And now you see it just doesn't snap when it starts moving. So I'm gonna set the random range back to like 2 seconds again. And I think that should be all. So there's randomness in when it starts and randomness in how fast it moves. And last thing, I am just going to replace all of these blockouts by our functional blueprint. Just copy and paste. You can just hold down Alt to make a duplicate. And there you go. It is going to be random every time. You have some swinging balls. You can probably make this a bit harder, but it works. So that's very nice. So if you don't really like how they're like static like this, if they start, you can just remove the wall. Like you can just remove this like set timer by event, which I'm going to do now to show you guys, and then just put it on move obstacle. So it's instantly going to rotate the obstacle. And what I'm going to do then is to increase this value a bit. so that you don't have them all in sync, but they kind of like go out of sync because one is moving a lot faster than the other. I think if I now play, there you go. I might actually keep it like this. I do like the difference in like speed they have. Makes it a lot like harder to navigate. All right, 6 obstacles done, 1 more to go, and that's these kind of like timed platforms. So how it works in Fall Guys is you stand on a platform and at some point they will just move and the player will fall to the ground. So I tried prototyping this in Unreal, but it kind of looks like this. So the player keeps grounded on the platform and the platform doesn't move away from the player. So what I'm going to make instead is instead of them moving, I'm just going to make them disappear and appear again, which also makes the code a little bit more digestible and easier to make. All right, let's get started. In our content drawer, in our obstacles folder, I'm going to create a new blueprint class, the last obstacle. It's going to be called BP_timed platform. And what we're going to make is just one of these platforms, not both of them, just one. And then we're just going to place 2 of them, or 3 or 4 or 5, or how many you want. So our viewport will be the easiest one so far, because the only thing we're going to add is a cube. And this cube also doesn't really matter. Just going to drag it out a little bit. Go back to our level, compared with our original platform. So I think just the x-axis can be scaled up a little bit more. Something like this. Let's assign a material. I don't think we have a material. Indeed, it's just the gray floor. I'm thinking maybe it would be nice to give it a new color for things that like despawn. Nah, I'm just going to give it the color red. Doesn't really matter. Give it a red color, compile, and it should be updated in our level as well. And that's pretty much all we have to do in the viewport. We don't need to add a collision box. We don't need to add arrows. We don't need any other component other than our static mesh, the cube. So the code is also going to be relatively straightforward. Again, we're going to remove the actor begin overlap event and the event tick. So we only have the event begin play. So how this is going to work is we just have 2 events. I'm just going to make them already, which is going to be hide platform. And you might already guess another event for show platform. This will despawn the platform and this will spawn in the platform again. Then when it hides, we just set a variable to after a couple seconds, it will show the platform. And then after a couple seconds, it hides the platform again. So it just loops between these 2 events. And to make sure not all the platforms will despawn and spawn at the same time, we give them an initial delay. And this initial delay we can set per instance of this platform. So I'm just going to show you how it works. So first off, we need a set timer by event, which after a couple seconds, create event, will call hide platform. This time input we're going to promote to a variable. We call this initial delay. And important, we're going to make this instance editable. So we can set the initial delay for each of these platforms individually. So that's pretty much all we have to do for now on the begin play. So it will call the hide platform. And what we need to do is we need to disable the visibility and we also need to disable the collision. If you forget to disable the collision, the actor will still have collision, but you just can't see it. So it doesn't really make a lot of sense. So you can just easily do that by set actor enable collision, which you're going to set to false. And then set actor visibility or set actor hidden in game, which you want to set to true. And then we're going to call a timer that will create event that will call show platform. And let's set this to like 2 seconds for now. Or maybe let's just promote it to a variable. Might be easier. Which we're gonna call time to stay hidden. Okay, not sure if I told you, but I'm using a timer instead of a delay. The benefit of a timer against a delay, there's a couple of benefits. For example, you can promote this to a variable, this timer. For now, let's say timer. Then if you're gonna get this timer, we can say clear and invalidate timer by handle, which will just cancel out the timer. It will just not run this event either. This wouldn't really be possible with delays. And another thing is if you re-trigger this timer, it will restart the entire timer. And delays would just ignore if it gets re-triggered. So usually I do use timers over delays, but if you like delays more, feel free to use delays. In this context, it doesn't really matter. So on the show platform, we're gonna do the exact opposite. So we can just copy these 2 nodes paste them in, but then we want to set the collision to true, and we want to be visible, so set hidden to false. And then don't forget to set another timer, create event, and we're going to say hide platform. I'm going to make this a variable, time to stay alive, and we're going to make this variable like 3 seconds. So that's basically all the code that we really need. And if I select the platform, we have the initial delay, but there's one little bug still, and that's if this value is 0, which it is now, it will never hide. Let's say we put it to like 0.5, it will hide. So we need to say, if this initial delay, and drag out of it, is equal to 0 branch, then we want to call hide platform. If it's 0, we're just overriding this timer because it doesn't run, so it will never call this hide platform. So in that case, it will just call the hide platform event regardless. I'm going to clean this up a little, add some reroute nodes like this. Just double click on the line, it will create a reroute node for you. I'll save. And now put this back to 0, and I start playing, it will be hidden. And after 2 seconds, it will appear again, and then it will be hidden, it will appear again. And that's basically how it's going to work. These swinging bars are going crazy, by the way. So I'll replace these meshes with the mesh that we created. Let's set the other initial delay to 2 seconds. Just play around with it and see what feels nice. Okay, so now the one spawns, but the other one despawns at the same time. All right, so I found 2.5 seconds to be a sweet spot for this, for the right platform, and just 0 seconds for the left platform. So by default, the right one will be spawned, the left one will spawn in. So there's half a second where both of the lanes or both of the platforms are active or spawned in. And that's basically all we really needed to do for this obstacle, which means all the obstacles are now in place. We're starting with these rotating propellers, and we'll go to the sideways moving platforms. And remember, the purple platform is a slow down platform. Then we get to these swinging balls. And these circular platforms with the rotating stick that will just launch you if you get hit by them. Then more swinging balls with a slow down platform on the bottom. Then we have our time platforms. And finally, for the final climb, we have our rotating hammers until you reach the finish line. So that's our obstacle course. And if you do want to make changes, you can of course lay out your obstacle course however you'd like. You can even combine some of these. So for example, combine the sideways moving obstacles with like these swinging balls, or combine the swinging balls with these circular platforms. It's all up to you, and you can go a lot of directions. It is quite literally just a matter of placing an obstacle in, placing another obstacle in, and there you go. We just kind of combined 2 obstacles. All right, with our obstacles moving, there's one more thing left to do for us before we close off this blueprints chapter, and that's making checkpoints. So every time you complete an obstacle, there will just be a checkpoint, and if you then fall to the ground, you'll just respawn to this place. So how I will make this is there will just be a huge like trigger box on the ground. This will detect player collision, and there will be a bunch of trigger boxes at the end of each obstacle. When a player goes through one of these trigger boxes, it will tell the blueprint to respawn the player here if it falls through the ground. And then if the player reaches the next trigger box, it will set this trigger box to be the most recent checkpoint. So in a content drawer, we don't want this to be an obstacle. For now, I'm just going to make it here in the content folder. It doesn't really matter because we don't have a lot of blueprints. I'm going to call this BP_checkpoint manager. So I'll start with making the huge trigger box. That's just box trigger, box collision. Just scale this up a lot. And over the X and the Y axes. You can always scale this up later in the level. But for now, I'm just gonna drag this in, see how big it is. We see it can be a lot bigger, pretty much just on the X axis. So let's do that. Make it a lot bigger, compile, and that's a little too big. Also, it doesn't really matter if it's too big. I'm just gonna keep it like this. So what I'm gonna do, I'm gonna make an array of type trigger box with instance editable. This way we can just place trigger boxes in a level, assign them to the blueprint, and then just like we've done before on Begin Play, we're gonna bind them to onComponent Begin Overlap. So what it will do is it will just take all those trigger boxes, they will place it in a level, we tell it to activate an event once a player steps through this trigger box, But we basically just want to say, okay, I just want this trigger box to be the current checkpoint. So I'm going to delete these 2 events. I'm going to make the variable called trigger box or checkpoint array, which is of type trigger box, just an object reference. And then we're going to select this array. Again, if you need more information about arrays, I made a video about arrays earlier. Make sure to check that one out. And importantly, we need to make this instance editable. Compile. If I now go back to my level, you'll see I can just add and remove any checkpoints now. These are just trigger boxes. Right now, we don't have a trigger box placed in the level. But if I would go to the place actors panel, which is right here, and I would go to basic and then trigger box. Right now, there's a trigger box placed in the level. So let's select my checkpoint manager again in the outliner. And now there should be this trigger box, which is this one that we just placed. So there's like a direct reference from the blueprint to this trigger box. That's important. Now on begin play, we're going to get this array. We're going to get a for each loop, just F and click, or just right click and search for each loop, whatever you want. And then we drag in the checkpoint array. So this will go over all of these checkpoints, all the trigger boxes that we placed in the level. And with all of those, we want to listen for overlap. So bind to on begin, on active begin overlap. There we go. We do that for all the ones. We're going to say create event, make an event, and we're going to say on checkpoint reached. So what's important here is the other actor will be our player that overlaps with the trigger box. And the overlapped actor is the trigger box itself. Now this overlapped actor, the trigger box that we overlap with, is important because we need to set this overlapped actor, the trigger box, to be the current checkpoint. So first we want to have a check, is it even the player that collides with it? So cast to a third person character like we've done a lot of times already. But since this is an actor object reference and not a trigger box, we need to make our variable an actor as well. So we're going to call this current checkpoint. This needs to be just a generic actor. So we had to make this actor and not a trigger box because it will only look at actors to overlap with. So a trigger box is an actor. You can check it by, if you right click in your content browser, blueprint class. Then instead of just selecting actor, you can go to all classes and type trigger box. And you see it's like a child of an actor, right? So actor has a child called trigger base and trigger base has a child called trigger box. So just making this an actor is perfectly fine. So we can just set the current checkpoint and then the overlapped actor, which is our trigger box, but also an actor, we're going to set it as the current checkpoint. I quickly want to test this, which I'm going to do by print string. I'm going to get the display name of the checkpoint and print string. Now the checkpoint manager, we still have this trigger box selected. So let's just rename this to checkpoint test. And I'll drag this down just make sure it's a bit bigger, like this. Just make sure you can't like juke the checkpoint. Something like this works for now. Let's test it. So yeah, it printed to the screen, checkpoint test. So it correctly identified the checkpoint that we just created. So delete the print string. Now when we overlap with a trigger box that's beneath our level, we want to teleport to the location of our current checkpoint. So let's make that. We're going to select the trigger box, scroll down, and then on the component begin overlap. If it is our player, so let's just use this cast. Then we want to teleport the player to our current checkpoint. So we're going to get a current checkpoint. We're going to get actor location and drag it into the destination location. I think for the rotation, we can just keep it as 0, 0, 0. Because if I look at the checkpoint rotation, it's also just 0 on the rotation. So I think this should work fine. Let's test it. If I now go through the trigger box, fall down, it will respawn us. It does respawn us the other way. So we need to give the z-axis a 180 degrees on rotation. So on z, 180. I can just hard code this value in the blueprint because I don't need to change it over the course of my level. The player will always respawn in this direction. Cool, let's test it again. Fall down. There you go. Now all that's left to do is just making more checkpoints. I am going to place these in a folder. You can do that by right clicking, move to, create new folder, click on a folder, press F2 to rename it, and we're going to call this checkpoints. To make a duplicate, remember you can just Alt and drag, place it up a bit. It will place it in the folder as well, which is really nice. All right, I've placed a bunch of checkpoints in my level. Now I need to go back to my checkpoint manager and assign all of these. So it's 1, 2, 3, 4, 5, 6 checkpoints. So make sure there's 6 elements in our array. And now we can just click on the pencil and then hover over our checkpoint and click on it. That's how you assign the checkpoint to your blueprints. Do that for all of them. That's 5 and that's 6. So now even if we start here, we go through the trigger box, we don't see anything, but if we fall down, we respawn here. But now for the sharp eye, you might have noticed that what if you start here, you don't go through any checkpoints and you fall off the edge here? Well, for that we need to have another check to make sure, do we even have a checkpoint to begin with? In other words, is it not null? Because if it's null, we just want to respawn the player to the player start right here. So I am going to make another variable called player start location of type transform. I'm not selecting a vector because I also want to have control over rotation. So compile, you see I can adjust the location, rotation and scale. We're going to make this instance editable and also show 3D widget. If you now compile, you see we have this like player start location, which you can just move around. We're going to move this to our player start. Actually, we need to select this instead. This kind of like diamond thingy. Otherwise you move the entire trigger box. We don't want that. And we're just moving this diamond, this gem kind of. And we're going to just move it right here. We want it a bit above right here so the player doesn't clip through the ground. Something like that. And then in the blueprint, the details panel, we want to set the rotation to 180. So it will always spawn the player in that direction, the same way how we set it up for the checkpoints. Then if we overlap with our floor trigger box, we first want to check if our current checkpoint is valid. And we want to select this one with a question mark. And this will basically check, hey, is this variable, is it not null? Does it even exist in the first place? If it does, we just teleport. If it doesn't, we'll also teleport the player, but to a different location. Actually, I'm going to place this after the cast because we will also need the third person character reference. And then we're also going to teleport the player. If it's not valid, this is going to be a mess, but I'll clean this up after. And then we want to get the player start location, which contains both the location and the rotation. So we're just going to get, I think we can break or split struct bin. Yeah, there we go. Which gives us the location and the rotation. Just clean this up a little, something like this. So what should happen is when we fall to the ground, this event will fire. It will check if it's a player. If it is, it will check, do we have a current checkpoint? So have we encountered any checkpoint or did we die somewhere during the first obstacle? If we have found a current checkpoint, great, we'll just teleport the player to the current checkpoint. If we have not found a current checkpoint, we'll teleport the player to our manual location, which is this player start. So let's also test this out. I'm going to play here. I'm going to fall off the edge and nothing really seems to happen. Let's check why that is. I think it is just placed too high. So let's make sure to place it a lot more down. Get a player start location, make sure to drag it up again. So I think the transform doesn't really work. I'm not too sure why. I've played around with it a little, but can't really seem to figure out why. So what I'm just going to do, I'm just going to add like a scene component in the level. It's basically like an invisible thing. We can just give it a location and teleport a player to that location. That should for sure work. So we have the scene component, which is going to drag it here. Make sure to rotate it 180 degrees. We're also not going to need the teleport anymore. So just delete it. Then we're going to teleport the player to the scene location. So get world location together with the rotation. rotation, drag them both in, and then on the not valid, we teleport the player. This should hopefully work. If we now jump off the ledge, there we go. We spawn at the right location. So that's basically our entire checkpoint system done. So if we don't have a checkpoint yet, we will just spawn back at the begin play. Let's traverse through this level, this obstacle. Then once we have a checkpoint, at this point we should have a checkpoint, we fall off the edge and it will spawn us right here. And finally, we'll add the UI, not as decoration, but as feedback. Timers, messages, and information that supports the gameplay. In our case, we're going to need a timer. So it's time for UI, and basically all UI is being made in a widget in Unreal Engine. So I'm going to create a folder called UI. We will only have one single element, the timer, on our screen, but for practice, it's just good to have a UI folder regardless. If we right click in the content drawer, we see this user interface drop down. Here we see the widget blueprint, and we can just create a user widget, which we're going to call WBP for widget blueprint underscore timer. So I think how I'm going to let this run is on my game state, which is kind of like a global blueprint that's in every level. I will have like a timer every second, and every second it will call to the UI to decrease 1 second of the timer. You can make this all in the UI blueprint, and if you want to do that by any means, go for it. But I like to keep these things separate because like the whole timer thing is kind of like the game logic, and how it looks is more UI. So when I open it, I have this screen. So first and foremost, I need a canvas panel. And if you're familiar with Photoshop, you might know that you first need a canvas in there to start working or to make things. And it's kind of the same here. We first need our canvas panel in order to drag any of these elements. Because if we try to add one of these elements, it will just be one huge square because it doesn't really know how big it should be. It can't really move them around. So let's place in a canvas panel. Just search for canvas panel right here. There we go. If we now, for example, drag in a text, we can just place it anywhere we want. I know there's ways in UI how you can make things perfectly centered. I'm not going to bother too much. I'm just going to make this a lot bigger. I did that, by the way, by highlighting the text. In the details panel on the font, you have this size. I do want to make this centered as well. So I think in the justification here, put it centered, and then we'll put it in the center. Just for the sake of it, I'm also going to add some shadow. And just keep the X at 0, I guess. And make sure in the shadow color you set the alpha to 1. By default, it's 0. I'm going to drag this up a little bit. Now, what's important is that we tick this is variable text box. I'm also going to rename this to timer. And then we can go into our graph, which is where we do some blueprinting. You'll notice we have some different events apart from the event tick. This, of course, we do have in normal blueprints. Then we have event construct and event pre-construct. So event construct will happen once you see the UI on the screen, and event pre-construct happens right before it. So when the UI is not on screen yet, but it's about to be added on screen. I will just use the event construct. Since on begin play, I want to have the UI on screen anyway. So here we have this timer. We can set the text, I think. Set text, this one. So what's going to be in this in text will be 2 variables, our minutes and our seconds. I'm going to make those variables. So minutes, which is an integer. Remember, integers are just full numbers, so no decimals. And then you have seconds. We're going to get them both. And then we want to say, I think from this one, format text. And then in here, if we do like this kind of icon, like the scribbly bracket, and then colon, squiggly line, SS, it will create these input variables for us. And we can put in any variable that we want. So it's a wildcard. So in here, it's just the minutes. In here, it's the seconds. And then we'll go to our set text. I do want to try this out. If I compile and just give these like a default value. So for minutes, I'm just going to give it like 5. And for seconds, I'm also going to give it like 3. And then finally, I'm going to the game mode. Open the full blueprint editor. And in here on begin play, I want to add the widget on screen. We want to say create widget, which is going to be our WBP timer. With this, we want to say add to viewport, like this. I think if we now start playing, we have a huge 5-3 on our screen. It is a little bit big, and I'm personally not too sure about the shadows. I'm probably going to remove that as well. So just in our timer, I'm going to remove our shadow, revert this, and scale it down by quite a lot. I do think that's a lot better already. It is pretty off-center. That's what I was afraid for. It's a bit more to the left, something like this. And we want to add a custom event, which we are going to call from the game mode eventually, which is going to be update timer, which is basically just the same code. If you want to be clean about it, you can also just put this into a function and just call a function on construct and on update timer. For now, I'm not gonna bother too much. And then we want to set these minutes and seconds and call the update timer from our game mode. So first and foremost, we need a reference to our widget. Well, we can already make that here. Promote this to a variable, which is going to be our timer widget. And then we want to set a timer. So create timer or set timer by event. Create an event. Oh, not a comment. Create an event. Also something like update timer, where we're going to get the timer widget. We're going to get the minutes and the seconds. I'm going to put this on 1, by the way, and loop it. So let's first just get the seconds and just do minus minus. This will just decrease it by 1. Actually, I think I want to do the calculations in the widget blueprint. Yeah, I'm just going to get the timer widget and call the update timer. Maybe this is a bit confusing. This event and this event are called the same. Maybe on second passed, because every second this will fire. So every second we update the timer. So we're going to move this to the right and then get our seconds, decrease it. So if it's 0 at this point, we don't want it to decrease, but we want the minutes to decrease instead and set the seconds to 59. So before we do this, we're going to check if it's 0. Then if it's 0, we want to get the minutes. Get one of those, subtract it by 1. And we want to set the seconds to 59. And if the seconds is not 0, we just want to get a seconds, decrease it by 1, like this. And finally, we are going to update the text again. So set text, like this. So I'm quickly going to check if this works. If I put this to like 2, and then seconds to 5 seconds, and then test it out. All right, one thing we forgot to do is after the false, we also still want to update the text. Previously, it would just do this, which is not update the text, only when a minute would change to 1. There you go. So make sure this one is also dragged into the set text, like this. And now when we play it, it will just count down, like this. It will change the minute as well. Then there's 2 more things I want to do. One thing is when it's 0, I want to cancel the whole timer so it doesn't go into the minus. Always make sure there's a default of 2 numbers on screen. So instead of 1, I want to say 0, 1. So how I can do that is pretty simple. So before we put this into the format text, we say to text, then integer, delete this line for now. And if I drag out, you'll see there's a minimum integral digits. Instead of 1, we say that should be 2. And that will be our new minutes. Same for seconds. Delete this line, say to text, and then minimum digits, it's going to be 2. I think that should always give out 2 numbers. Let's test it out. There you go. You did see on construct, it did not do it. Therefore, I think it might be better after all to just make this like one function. We don't have to do like duplicate work. So just select all of these, right click, collapse the function. Let's call it something like set time. We're gonna call here as well. So let's test it. And now from the start, it will already give out 2 numbers. I'm going to get rid of these spaces, I think. See how it looks. Yeah, that looks a lot better. It's a bit more compact. All right. Now the last thing is we want to have a check to see if it's 0. I want to do that in the game mode. So before it's going to update the timer, I want to check on the timer widget get the seconds and get the minutes. And if both are 0, so if this one is 0 and so Control C, Control V, this one is 0, we want to use the AND Boolean. So if the time is 0, we want to clear and invalidate this timer. So also make sure to make this a variable called timer. Then we want to make a Boolean here. So if if time is not 0, we can safely update our timer. If it is 0, for now I'm just gonna print string something. You can make like a game over screen that you would also just call from this game mode, make a UI for it, and also just create like a widget for it. And then just create widget and add it to the viewport. But for now I'm just gonna say game over, make it like red and be on the screen for like 10 seconds. Let's clean this up a little. Just add a reroute node here. All right. Then the default values for now, I'm just going to say minutes is 0. Seconds is going to be like 5. It's fine. Play it. It's going to count down to 0. And when it's 0, it should say game over. There you go. Game over. It will call out like a lot of times because I forgot to set the, or to clear the timer. So after setting it to game over, I want to get a timer and then clear and invalidate the timer. Like that. So now it counts down 3, 2, 1, 0, game over, and that's it. So to recap this part about UI, we started in the designer where we added a canvas panel and then a text block. A canvas panel is there to place objects in. So we did that with our text block. This became our timer and we set this to be a variable. By default, it says it's text block. And because we take the is variable, it will change this text block here in the graph, where on construct, we set the time and we set the text of the timer. And this timer variable is the variable that we created here by ticking this box. Then we made 2 variables in the widget, minutes and seconds. We converted them into text because we can then set the minimum amount of digits. We formatted it into minutes, seconds. And then in our game mode, on begin play, we create the widget and we set a timer every second. We made sure it's looping. So every second it will call this event, which first and foremost will check if both the minutes and seconds are both on 0. If that's true, it will print game over and clear this timer. If it's not on 0, it will update the timer, which we do in the widget. Here we check if the seconds variable is 0. If it is, we subtract the minutes and we set the seconds to 59. If it's not 0, we just subtract 1 from the seconds variable. And then we're just setting the text like this. And that's pretty much all. It's just a bunch of basic math with integers. If you would like to do all this game mode code in the UI, that's fine. I don't think you can make a widget and add it to the viewport. So you will have to use a blueprint for that, but everything else you can do in the UI blueprint, I think. But again, personally, I like keeping things separate. So keeping my like logic/gameplay stuff here in the game mode and keeping UI related stuff in the UI blueprint only. And that's it. These are the most fundamental topics you need to understand to make games in Unreal Engine. And trust me, there's a lot more I can cover in this video. Animations, materials, multiplayer, AI, you name it. But all of those features, they build on the foundation we learned today. Remember the 80-20 rule. You use like 20% of the Unreal Engine features like 80% of the time. Once you understand these fundamentals, the rest becomes a lot easier to learn. If you made it to this point in the video, congratulations. It seems like you're really committed to learning how to make games in Unreal Engine. If you want to go deeper, I've made a bunch of other videos where I dive into these systems in more detail and explore more advanced Unreal Engine topics as well. I would highly recommend checking those out next. I've also made a Discord server where you can ask any questions, you can talk with me, talk with the community, and learn more about the process of making games in Unreal Engine. If this video helped you understand Unreal Engine a bit better, I would really appreciate a like and let me know down in the comments what you're building. And if you want more videos like this, I would also appreciate a subscribe. It really helps me a lot and it helps out my channel. Good luck on your game dev journey and I hope to see you in another video.